Lab 1, Constant Velocity by Kevin Wynn. Introduction. The purpose is to show that things can stop in the real world, and this is what I found out, that the round thing that we rolled stopped in the real world, but the computer made it kept going. Main idea, the thing rolls forever because math is cool and you just kind of don't worry about like friction and stuff. I don't know. The main concept, that net force is equal to zero. Since we're trying to observe constant velocity, no other force is present except for the thing that's pushing it, because constant velocity. Here's the model. There's a hand, pushes it, rolls, second frame. More detailed explanation is that someone rolled a dowel and a meter stick was used for scale. The dowel moved and we tracked it using tracker to upload data and stuff. Of course, since it only went in one direction, the data reflects that only the x direction was really measured. Looking more closely at the model, the dowel was the system and everything else was the surroundings, meaning the table, gravity, maybe like friction was a factor in this. Initial conditions, the initial push caused, the velocity of the dowel, and I record the dowel as it passed the meter stick, or start to pass the meter stick, so it would start at an origin if I were to set a coordinate system. Here's the code. Explaining the code, I gave it an initial velocity of 0.025 based on calculating a change in velocity between 2 points, then added the position vector in the while loop, which looped 120 times with a time step of 0.01. Then also added some other data points that really didn't factor into the code, but just for like physics sake, I added in mass and net force, even though net force is technically zero because it's constant velocity. Here's a picture of the code running. Of course, position over time. Look at the ball go in a direction. Here's the results. Obviously, the code increased constantly while the experiment tapered off. What really happened is just like, the code was literally just a number counter, just added continuously. Obviously, it would go in a very linear fashion and had no taper. Sources of error, maybe I just didn't understand the lab. Maybe, I don't know, maybe I coded it wrong, or maybe I tracked it wrong. But if not, then the computer just adds stuff up and doesn't really account for anything like friction or gravity, slowing it down, or really anything at all. It just, adds stuff. Maybe I also did the code wrong, who knows? What if other variables were accounted for, maybe the computer model would actually kind of match the data more, or, like if the coordinate systems are matched around, the graph would just go down because, going negative, so negative position over time. But, like, yeah, if, other factors were added in, maybe like a little friction here or there, maybe we get like a taper, and it actually kind of look like the graph. And that's it. Thank you.